Apache Cassandra and DataStax. And I focus on the .NET community. So like Patrick said, he hired me. I guess I've been with the company since February, and he said, hey, you know, we haven't really talked to the .NET community really at all, and you know, there's this whole other side. And so Patrick and I actually worked together at a previous job. So just real quick, life as the .NET evangelist. I kind of feel like, I don't know if you guys get the reference, but I kind of feel like the witch from Monty Python, like burning, because it's full of the company DataStax, with Apache being, you know, Cassandra being an Apache project and everything like that. You don't tend to get a lot of .NET or Microsoft guys. You tend to get a lot of Linux and Java and Python and all these other kind of things. So, you know, like you say the word Microsoft and people are like, kind of like cringe. You know, like, but actually the funny thing is, you know, the .NET community, the C# and Microsoft themselves even have really gotten an open source love recently. So like in the last few years, there are a ton of awesome .NET projects that have come out. You know, you go on GitHub and find all kinds of good stuff. And even you know, the fact that you can go on GitHub right now and grab like the whole ASP.NET web stack from Microsoft, the official web stack, and it's under an Apache 2 license, like blows my mind, basically. You know, like it's really cool that you know, they've kind of got to the bug. So just real quickly about me, my background, like I've been an application developer forever, so I've been building line of business apps. Patrick and I worked together at a previous company. We were in the education space. We had a really big CRM. That was kind of a big distributed system used by hundreds of colleges and universities you know, across the country. So my job as the language evangelist, or sort of my interest, I guess, as a language evangelist, is really how do you build stuff on top of Cassandra, right? So like you guys have probably heard some stuff about internals maybe, or I don't know if they're teaching that at the advanced track. You know, the how Cassandra works stuff isn't nearly as interesting to me as like, what do I use it for? Like, what am I going to build on top of it, right? You know, because that's been my background, is building applications. So I'm going to talk to you about the C# driver. If anybody in here is not a C# person, that's totally cool. A lot of what I'm going to say actually applies to the other drivers as well. So one of the cool things about the DataStax drivers is that a lot of the concepts are very, very similar. So if you're a Python person, or if you're a Java person, or now C++, I think, is our latest driver that might be in beta right now. A lot of the concepts are the same, so a lot of the class names and stuff that I'm going to talk about, like those also apply in the other drivers as well. So keep that in mind. So first thing to know, where to get the drivers. So like most projects these days, most .NET projects, you've got a NuGet package, go grab it, use the package manager to install it. You can also go to GitHub if you want to check out the source. It's github.com/datastax. Click on the C# driver. We just came out of 2.0, so 2.0 beta, so it just became GA. So there's a lot of cool new features and stuff that you can now take advantage of if you're using the C# driver that you couldn't before. Probably some of the stuff that Patrick talked about this morning, like lightweight transactions and that kind of thing, which I'll talk about kind of towards the end of the presentation. All right, so let's start from the beginning. We'll talk about bootstrapping the driver. So the first kind of most top-level object that you need to know about when you write code is the cluster object. And it's a singleton, so you're going to create one per application, unless for some reason you're in a scenario where you're talking to multiple Cassandra clusters. Chances are, most of the time, you're going to be in a single application or inside of a service boundary, maybe in a SOA kind of thing. You're going to be talking to a single cluster, right? So singleton one per application. You get it by doing cluster.builder. And then it's a Fluent style interface, which are all the rage everywhere, like a builder Fluent kind of interface where it's chainable method calls. All you have to really tell it to get started is you just have to tell it the address of one of your nodes. So in this case, I'm running on localhost on 127.0.0.1. And so really, that's about as easy as it is to get a cluster object. Call build at the end to actually get the object back. If you had, if you had multiple nodes that you wanted to tell it about, you can call add contact point multiple times, that sort of thing. Like I said, Fluent interface, lots of options. So the point of this slide really isn't to kind of go over all the various options that you see here, but it's just kind of to show you like there are a ton of options available. So I'd encourage you, grab the driver, go to Visual Studio, do cluster.builder. And then see what you got with Visual Studio IntelliSense. You'll see tons of stuff. It's a pretty discoverable API. You can see here we're turning on SSL, we're using authentication because you can use authentication, setting some default query options, that sort of thing that you can set at the cluster level. So, like I said, we won't go into a whole lot of detail, but there are lots of options available to you. So the next object, once you got the cluster object, and that's kind of your top level object, then we're going to talk, this is the one you're going to use the most or kind of interact with the most, it's the session object. The session object is a singleton for key space. So again, this is probably the common scenario is you're going to have a single cluster and you're going to have a single key space in the cluster, right? So you're only going to be talking to one key space. But it is possible you could have multiple, but singleton for key space. So this will probably end up being a singleton object for you because you're only talking to a single key space. You get it from your cluster object. So you see the sample at the bottom. You just call cluster.connect and you tell it what the name of the key space is that you want to connect to, and you get back one of these session objects. And just a note on the naming, it was kind of inspired by the nhibernate or the hibernate session object. So if you've ever used either of those libraries before, a lot of people, especially if they build web apps or something like that, session means something totally different to them. So session might be browser session to you, or it might be the actual session object in the ASP.NET Web Stack. In this case, the name was inspired by the nhibernate session object, which you use to execute queries. So that's, if you're confused, that's where it came from. Because everybody these days, or not everybody, but most people, a lot of people in the .NET community are using IOC containers. They're doing dependency injection, that kind of thing. I just wanted to throw this example up real quick. This is just kind of a combination of the last two slides, the last two code examples. So you've got your cluster object that you're building, you've got your session object that you're building, and then down at the bottom, I'm using Castle Windsor in this example, but if you're using NuGet or AutoFac or pick your container of choice, basically, we're going ahead and registering it then with the container. And since I'm using the instance method here, it's going to treat it like a singleton because I'm providing it the single instance to reuse over and over again. So I just kind of wanted to show you. A good thing to remember is that you're going to set this cluster and session stuff up at the beginning of your app. So you'll do it in, if you're doing a web app, you'll do it in app start, or a console app or a service, you're going to do it right at the beginning. Kind of your bootstrapping code, the rest of your bootstrapping code. All right, so let's talk about statements. So statements are actual queries. So I'm sure Patrick has been showing you CQL samples all morning. And so these are the three sort of statement types, essentially, that you can run with the driver. And like I said, a lot of this carries over to the other languages, too. So it carries over to Python and Java as well. So the three types are SimpleStatement, prepared and bound statement, which are kind of two halves of the coin. We were joking. We were trying to come up with famous pairs earlier this morning, and we came up with peanut butter and chocolate and Bert and Ernie and all this other kind of cool stuff that they're going to use next door. But they're kind of think of them as they go together, but prepared and bound statements. The last type is batch statements. So I know Patrick was talking about batch statements. We were just talking about logs, the atomicity guarantee that you get, and so I'll talk about that a little bit as well. So we'll start with SimpleStatement. SimpleStatement, imagine it's an aptly named class. It's simple. So you create one by just providing the CQL string. So you can see here, select star from users, where user ID equals question mark. And you may have already seen, you probably have already seen this, but in case Patrick did not mention this morning, you can do parameterized queries with the driver in CQL. So the question mark in this case is just a placeholder for a value. So if you're used to SQL Server, where it's the @ sign, or Oracle, where it's a colon, same idea. It's just in CQL we use question mark as a placeholder. So you can see here I'm binding the value 145 to user ID. In reality, user ID would probably be like a UUID or something, not an int, but for examples there. Simple statements, they're good for one-off statements or dynamic CQL where you're going to be running like a slightly different statement every time. Maybe you're like dynamically building a where clause, or you're dynamically building a select statement or something where the CQL is going to be just a little bit different every time you run it. That's kind of the use case, or when simple statements can come in handy. Or they're good if you're just prototyping and you just want to kind of write something really quick, and I just want to run a quick statement with the driver against the cluster. Now, prepared statements and bound statements. First let's talk about how you get one. So we're going to start with the session object here. So that's the session object that we showed you how to bootstrap at the beginning there. And you're going to call session.prepare, or there's also an async version of this. So if you're doing the task-based stuff from .NET 4, or you're doing the async await stuff in 4.5, there's also a prepare async version of this. And the reason being that there is an async version of this is because when you call prepare, you see you pass in the CQL string, there that you want to prepare, but you don't actually provide the bind variable values. So what it's going to actually do is it's going to actually make a server round trip, and you call prepare. And this is sort of an optimization step. So the idea is that I prepare once, and then I reuse that prepared statement over and over and over and over and over again for queries that I'm going to run over and over again. And why we do that, why we pass it back to the server, is it can go ahead and like pre-parse that CQL statement, figure out the execution plan ahead of time and all that kind of good stuff. And then we save essentially having to do that every time we run for statements that we run a lot. We don't have to have Cassandra do that for us every time we want to run that statement, right? So that kind of makes sense. So the other thing to know is that once you prepare a statement, you should actually save this prepared statement instance off to probably something like maybe a class level variable, like if you got a DAO class or something like that. You want to actually save that prepared statement instance off because you don't want to pay the cost of preparing over and over again. You don't want to keep preparing. This is supposed to be an optimization, right? So once you prepare it, do that once, save it off somewhere, and then when you actually want to execute it, that's where the other half of this, a bound statement, comes in, right? So here I'm showing you how we actually then provide the values. So if you saw in the last example here, we're doing where email equals question mark. So here I'm actually providing the email value. And I'm doing the prepared statement that I saved off somewhere, .bind, and then I get a bound statement back, and that's one that I can actually execute. That's one that can actually be executed against Cassandra. And the other nice thing about this, one of the other optimizations essentially that this can do, is that when it actually goes to execute against Cassandra, behind the scenes it only has to send your bind variable values. It doesn't have to send the CQL string every time. So that's another thing that can kind of save us on latency. We don't have to keep sending the same string. And if you think about it, like in a lot of applications that you build, even on relational databases, SQL, right, we're running the same queries over and over and over and over and over again, probably just with different parameters, right? So we're doing parameterized queries of some kind, and just the values essentially that we're plugging in are changing. So you will probably use these in your most common use cases. You'll use these all the time. This is like, like I said, SimpleStatement, kind of a unique scenario, but this one you'll use a lot. Okay, so batch statement. Batch statement, like we talked about this morning about batches. The primary use case for batches is, as we've learned about Cassandra, we want to denormalize on write. So we've got, let's say, users signing up for user accounts, on our website. And as they sign up, we might have two tables. One's their user credentials so that we can authenticate them, which is keyed by their email address. So we've got their email address and password. And then maybe we've got their extra profile information, like their first name, last name, all that kind of stuff. And maybe that's keyed by a UUID of some kind, like a user's by ID. And what we would want to do when they sign up for the application is we want to denormalize, right? So we want to write to both of those tables at the same time. We do two insert statements. And to do that, what we're going to do is we're going to actually put it in a batch. And so you can see to create one of these is pretty dead simple, right? So we just do up a batch statement here. And then we add, this is just to show that you can mix simple statements and bound statements in batches. So you can mix and match. Like Patrick said, you want to keep your batch size small. Because there is an overhead associated with batches. Like he mentioned right toward the end of his talk, batches are logged. So they're atomic by default. That's the default kind of batch type, and that's the primary use case really that you should be using them for. If you ever start digging in and you want to actually do one of the other batch types, and there are other batch types available to you, you can set the batch type on the statement. So there's unlogged, which is another type of batch which doesn't have the atomicity guarantee. So it's faster, so you don't have the overhead that you have with the atomic batches. And then counters, you've probably already heard many times, counters are kind of like their own little thing where there's like lots of funky rules and things about counters. Batches are another case where counters kind of have special rules. They have their own batch type. You can't mix and match counter mutations with other statements, essentially. So they have their own batch type if you want to match counter mutations. So the other thing to know about statements is that you've got all kinds of options. So there's a bunch of stuff that can be set essentially on a query by query basis or on a statement by statement basis. So you can set the consistency level, you can set the retry policy, you can set paging size if you're going to use automatic paging, which we'll talk about automatic paging here in a few minutes. You can turn on tracing so that if you want to get a query plan and kind of see what's going on with a particular query, you can do that, and that's all available to you in the driver. And if you don't set it, it's actually going to fall back to some of those options that you set when you do the cluster builder stuff at the beginning. So you can set defaults with that cluster builder, and it will fall back to those if you don't actually go ahead and set them at the statement level. So this is just an example real quick of just the options that I listed. We're setting a page size for automatic paging, we're setting a consistency level, and you can see it's chainable, so it's another kind of fluent style kind of builder type interface when you're creating your statements. So just an example of those options. All right, so now we're going to talk about actually running those. So now we know kind of how to create the statements. Talk about running them. So you're going to actually use your session object again. So just like we did for preparing statements, you've got options on how you execute. So you can do synchronous or asynchronous. So synchronous, it's obviously going to block your thread while it's waiting for a response from Cassandra. So that's the first example up there. Asynchronous, like I said earlier, if you're doing the task-based stuff from .NET 4 or async await from 4.5, then you'll probably want to use the async, and that won't actually block your thread. That'll let something else go and do work. Potentially, it'll potentially yield control to something else and let that thread go do something else while it's waiting on a response from Cassandra. You'll see that in both cases, we get back a row set. So what is a row set? So a row set implements IEnumerable row. So if you're a .NET programmer at all, you're very familiar probably with the IEnumerable T interface. It's all over the place in the framework, right? And then on an individual row, so IEnumerable row means we can iterate over it, right? We've got a collection of rows essentially that we can iterate over. On an individual row, we can use the getValueOfT method on a row to get a column's value. And there's two ways that you can get at a column's value. You can do it by column name, or you can do it by ordinal / position. So what kind of what order it was in your select statement. And I'll show examples of both of those. Oh, and I should also mention the T in getValueOfT. That's just the .NET type of whatever column value it is that you're getting. And I'll show you some of the mappings from CQL data types to .NET data types and kind of how we make the transition back and forth, how we map them back and forth. So because row set implements IEnumerable row, obviously the first thing you can do is you can iterate it with a for each. So you can see here we're doing session.execute, and we're getting back some rows, and then we're doing a for each row in rows. And here we're building some sort of return list of DTOs. So we've got this video preview DTO, and we're translating one row at a time to this list of DTOs essentially. And you can see that we've got some different values for the getValueOfT. We've got GUID, datetime offset, strings, different data types. And here we're also getting by column name is the other thing to notice probably. So here we're doing video ID, added date. We're getting the values by the column name in the row. Now also because row set implements IEnumerable row, we can use any of the LINQ to objects stuff that I'm sure you guys have used 100 times. So this is that exact same example basically on the last slide, only this time we're using a LINQ to object select to project it to a new video preview DTO. You'll see the data types are the same for getValueOfT here, but the big difference being that here we're getting by ordinal or by column position instead of by column name. So that is available to you if you want to do it. And then the last thing maybe that's kind of interesting or that you'll end up using a lot is that you can also use LINQ to objects, the single or default method, which is kind of nice if you're doing a query where you're only expecting 0 or 1 rows to come back. So you're querying by a unique identifier, some sort of UUID of some kind. And so you'll end up doing this where you do rows.single or default and check to see if you actually got any sort of rows back. Or you got your 1 or 0 rows. And the good thing, we know single or default, if for some reason we were to get 2 rows back, it'll throw an exception. All right, so like I mentioned, we have mappings between the two, between the CQL3 data types and .NET data types. It's pretty much about what you would expect. I don't think there's probably any surprises on this. This is a condensed list, so this isn't a full list. If you go to datastax.com/docs and click on the C# driver, you can find a full listing of mappings, type mappings, including maybe the kind of thing that's missing here is collection types. So you have set, map, and list in CQL, and kind of what those map to in .NET. So go check it out if you want to see the full list. So now we're going to talk about the driver 2.0 features. So some of the new stuff that that probably we talked about a little bit this morning already, and kind of how you use it with the 2.0 driver. So first, the first new feature is lightweight transactions. So until like I said, the 2.0 driver actually just came out of beta. So until recently, you couldn't do this in C#. You couldn't take advantage of lightweight transactions until recently. So lightweight transactions, you use them when you don't want writes to step on each other. So this is sometimes called linearizable consistency, or if you're from the relational world and you've done a lot of relational stuff, you may know serial isolation level, where we only have one writer essentially at a time, and we want to make sure that something doesn't kind of step on, the writes don't kind of step on each other. I'm sure Patrick mentioned this, that if when you use lightweight transactions, there is a cost associated with it. It's a pretty heavy cost associated with it, but this is part of Cassandra's tunable consistency story, right? So we talk about tunable consistency. I can kind of pick and choose what consistency level I want when I want it. And lightweight transactions are really another tool in your tool belt for when you need it. Go ahead and use it. But there is a cost associated with it. If you go to the DataStax dev blog, Jonathan Ellis did a great blog post about this, where he talked about how at the coordinator level, under the scenes, like the Paxos thing the Paxos algorithm has to do like 4 round trips or something, and there's a latency cost essentially involved in using it. So use them when you need them, but don't go in thinking I need to use this everywhere. Unless really, it would be interesting to see a scenario where you really needed to use them. A canonical example that we always give for when, like, what you would use lightweight transactions for is unique user accounts. So you got people signing up for a website, and they're going to sign up and maybe put in a username, and we want to make sure the 2 users, if for some reason they were both trying to get the same username at the exact same time, that we don't have 2 people sign up with the same username, or we don't have 2 people sign up with the same email address or something like that, right? So that's kind of like the example that we always use when we're talking about this. And what does that actually look like? So this is kind of showing that scenario, right? So here we're just using a simple statement, and you'll see the CQL string looks pretty much like what you've seen before, and the if not exists, that's the CQL syntax for lightweight transactions, or one of them. I think there's another way to do it as well, but it's not saying we're going to use lightweight transactions, that part of the CQL statement. And you'll see that when I actually execute that statement, what comes back is I get a row set, but I'm going to get a single row back, so that's why I'm doing rows.single here. And you're going to actually get a special column back that's called applied, and it's inside of square brackets. And that column is basically going to tell you whether or not the mutation you just tried to do, whether or not the insert you just tried to do, the new user you just tried to create was successful or not. And this might be different than what you would expect if you've done a lot of stuff with relational databases before. You might expect like some sort of primary key violation or a unique constraint violation or some sort of exception basically to be thrown. Not the case with Cassandra. You'll get this column back that says true or false, basically whether or not it succeeded. All right, automatic paging. So automatic paging, the problem it was trying to solve is that so a lot of times, because Cassandra is so good at writes, a lot of times we're dealing with, this is big data, right? So, everybody loves that term. A lot of times we're dealing with really, really large result sets, really, really large record sets. And loading big result sets into memory is like a recipe for disaster. You're basically like setting yourself up for fail. So we're talking, I put out memory exceptions on the slide, but you're flooding your network while you're trying to load this humongous data set into memory. Just bad idea, right? So a better way, normally what you see people do when they want to sort of go at this problem is they'll want to load a large record set in pages and process it in chunks. So I get one page, download it, grab it from Cassandra. I want to start processing, do whatever processing I need to do, throw those records away, and then I go get the next one and do the same thing over until I'm done. This was like a really big pain in the butt with Cassandra prior to 2.0, prior to automatic paging. So you had to write a lot of extra code where you kept state, and the CQL statement had to change every time so that you could do like a where to get the next page. You had to keep track of what the last record on the page. It was a really big pain in the butt to do. So the idea with automatic paging was, for people that are dealing with these really big record sets, let's make it easier for them to essentially iterate through and process a really, really large record set. Let's make the amount of code that they have to write a lot less. So let's make the paging part transparent. And what does that actually look like? So, like I mentioned earlier about options that you have when you, at the statement level, you do the set page size. That's how you actually set a page size for automatic paging. So I'm saying I want chunks of 100 in this case. And you'll see in our example here, we're executing some sort of statement, and we expect it to get a really big row setback. And then we're going to go ahead and iterate over it for each row of rows. And as you iterate, what's going to happen is it's going to go ahead and iterate over that first page of records that it grabbed. And once it runs out of rows in that page, behind the scenes, it's actually going to make another call on your behalf to Cassandra to grab the next page of records for you. So you don't have to do any of this sort of state management where I'm keeping track of, oh, what CQL statement do I have to run to get the next page and all that kind of good stuff. The call is essentially transparent. So you just write the for each loop, and it'll let you iterate until it runs out of records, basically, until it runs out of pages of records to get. Now, one thing to keep in mind is that because your for each here is actually making a call to the server behind the scenes, that you could actually get an exception, right? Like, so for some reason, like the query to get the second page or the third page times out for some reason, your iterator here, your for each loop could actually throw an exception or something. And like I said, it'll allow you to iterate basically until you've gone through all the pages and records. So it makes it just a heck of a lot easier if you're dealing with a really large record set. It just makes it a lot easier to process. One thing that I wanted to mention about automatic paging, because my experience with Cassandra, I've been using it since roughly February, and so I'm relatively new, when it comes to this. Like I said, I've been building applications for a really long time, but not on top of Cassandra, mostly on top of relational stuff. I did want to mention this sort of typical paging scenario, because when I heard automatic paging, like I was like, yeah, okay, automatic paging, like that's, I'm thinking of paging scenarios that I deal with all the time. I'm like, oh, it must be for that really common paging scenario that I do all the time. So this is an example of the most common paging scenario, in a lot of web applications. I want to show a table or a grid or something like that, and I want to show one page at a time, and I want to let the user page through. I want to have next page and previous page buttons, and I want to let them click the button when they're ready to go to the next page, and so on and so forth. In this case, automatic paging, this is not the feature you are looking for. I feel like I can make Star Wars jokes, but this is not what automatic paging is for. So automatic paging, like I said, is for really large record sets. That's the problem that it's trying to solve. There is a way to do this typical scenario with Cassandra, and actually I was going to throw some slides in here. I had some slides in here, and I cut them out because just for time. But if you guys want to know how you actually do this sort of scenario, come find me afterwards, or I'm going to do. I'll probably actually do a blog post on it pretty soon on how you actually do this kind of scenario. All right, so just a few other things to mention about the driver, just kind of to wrap up a little bit. So .NET developers, we are all very comfortable or familiar with LINQ at this point. It's been around for a while. So as part of the NuGet package that comes with the C# driver, you're actually going to get a LINQ to CQL driver. So if you are familiar with LINQ and you like querying with LINQ versus learning CQL, and you should still learn CQL. Don't just rely on LINQ. But it is there for you. It's in the Cassandra.data.link namespace. It has support for all CRUD operations. Now, if you're like me and you think of LINQ and you think queries, that's the select side of things, you might find it weird that we have create and update and delete syntax in the LINQ driver. I think that is weird. I've set that to the, we'll see what happens. But there is syntax for create and update and delete statements as well in the LINQ to CQL package. I'm going to show you a quick example of what it looks like to use it. So the first thing you're going to do is you're going to start by creating a class of some kind that represents a row in your table. And you're going to decorate that class with attributes. So there's a table, column, and partition key are the attributes you're going to use. And that looks something like this. So in this case, we've got a user credentials table. And so we created a class to represent a row in it. And so we use the table attribute on the class so that it knows sort of what table this class maps to. Same thing with column. So we decorate each of the properties with the column attribute. And then this particular this particular table, the user credentials table, is keyed by email. So that's what the partition key attribute that's up there is for. When you actually want to run a query, then this is kind of what it looks like. So you're going to use the session object again. Like I said, that's going to be sort of like your main entry point. You're going to call session.getTable of T, and that's going to be provide your class, so in this case use your credentials. And then off of that, you can go ahead and do all your typical LINQ operators that you're used to being able to do. So in this case, I'm showing a simple where clause, so we're saying where email address in the table is equal to whatever email address they passed in. And again, there's execute and async execute methods, so if you're doing the task-based stuff, the async await stuff, there is async available for you also to execute queries via LINQ.
So the session here is all singleton you already defined at the local level?
The session, yeah, exactly. So like in this example, like you'll see session I'm using, like I actually copied this, so I'm going to mention in a minute that a lot of these examples are from this sample application that we built, so called Killer Video. And so in this case, this was just a data access method that I actually copied from that, where session, you'll see it starts with an underscore, and if you're used to that naming convention, that's a lot of times that's a class level variable. So in the example, what's happening is session's being injected by a dependency injection container, so it's coming in the constructor and being saved on. So and you're going to reuse your session object, because under the covers, it's actually kind of heavyweight. It's managing connection pools and that kind of thing. So you definitely don't want to be creating those over and over and over again.
So when we use in the where class, anything that is not in the index, does it throw the same error that is?
Yeah. So what'll happen is when you do where, I mean, it's going to actually take your LINQ statement, translate it to CQL, and then run a CQL under the covers. It's going to be using sort of those core objects that I showed you earlier, SimpleStatement, prepared bounds, that kind of stuff. That's what it's going to actually be using to actually execute statements under the covers. So you'll get the same sort of errors that you would get with the LINQ driver that you would get if it was, make sense? Okay, another thing that comes in the NuGet package is an ADO.NET driver. So if you've done a lot of ADO.NET code and you're really comfortable with ADO.NET, it is there. It allows you to use your favorite in parentheses, and I say favorite because I don't know that anybody really likes ADO.NET, but if you have favorite ADO.NET objects like DB connection, DB command, data reader, all that kind of good stuff, it is there for you. My recommendation is avoid it, honestly. So there's been this debate on the Java side as well, so about having a JDBC driver, I think, and it's like just a lot of concepts in Cassandra don't map well to ADO.NET. So a good example would be, we talked about prepared and bound statements. Like, there is no concept of that in ADO.NET, like preparing something and then reusing it, over and over and over and over again, right? On the other side of the coin, ADO.NET has transactions, right? But inside of Cassandra, we don't have any concept of transactions. So it's kind of a mismatch between the API that you're going to get with ADO.NET and what Cassandra is actually doing. So that's why I'd say avoid it. Use the core stuff, or if you want to use the LINQ for querying, use that if you want. But you're going to end up painting yourself into a corner probably if you use the ADO.NET stuff, where you can't take advantage of some of the newer stuff as it comes out. And, you don't want to be in that situation. But if for some reason you want to, it is there.
Is that from DataStax?
Yeah, it is. So it comes in the same NuGet package. Yeah. So you'll get, I think you'll get 3 assemblies or actually maybe 4, because there's one for DSCL authentication that comes with the package as well. But, yeah. Okay, so like I mentioned, there's the Killer Video sample application. So we went ahead and there's like a dearth of .NET and Cassandra examples out there. There's like nothing, and that's because I don't know, we just haven't had anybody to do examples yet. So Patrick had this idea, and he's had this schema on his GitHub repo forever, and he actually had a slide deck around it where he had sketches of this website. It was a video sharing website, and you could go and grab the schema off his, and it had sample queries and stuff in his GitHub. And we went ahead and actually built this website, right? So he had this idea, we built it. I built it on top of ASP.NET MVC, and it's using the DataStax C# driver to talk to Cassandra. So if you want to go grab it, it's on my GitHub, github.com/Luke-Tillman, and you can click on Killer Video C# and grab it. It's got all the examples that I showed in this slide deck here are pared down examples from basically from that app. So go grab it, and there's tons of other examples in there if you want to kind of see how you do stuff. Multi-gets, for example, that kind of stuff is all inside there. And also, if anybody, if you have other examples that you want to see that aren't in there, definitely like pull requests or send me a message on Twitter. We're trying to basically make more content available out there for us .NET guys. So lastly, just real quick, what's next? What should I look at next? You probably already heard this before. Data modeling, data modeling, data modeling. Like if I could tell you anything to go check out, especially if you're from the relational world, go check out data modeling. Patrick's got a great series of videos. Actually, if you go grab the Killer Video app, down in the footer, there's like links to data modeling. There's like links to the Cassandra wiki that has a bunch of stuff on data modeling, including his series of videos. If you go to planetcassandra.org, you can get videos, drivers. I'm sure you guys may have been on that site already just to grab Cassandra, right? So drivers, documentation, tutorials, all that kind of good stuff is all available on Planet Cassandra. And lastly, because I have to say this, follow me on Twitter for updates if you want. So I'll be tweeting not only about Cassandra and .NET and hopefully new stuff as we add more stuff to Killer Video, and we'll probably develop a whole bunch of other sort of use case example code, that kind of thing. But I'm hoping to actually get to do some other stuff, maybe some Scala, or maybe some Node. Like, I don't know, we'll see. I mean, I haven't always been just a .NET guy, so follow me on Twitter, and like I said, send me if you've got requests for like examples and stuff, or you have questions, that kind of thing, as you're digging in. Don't hesitate to send me a DM.